In this video, we're going to turn our attention to a new section in which we're going to focus on fallacies. And specifically, we're going to focus on informal fallacies. And a fallacy is a mistake in reasoning. So it's a defect in the argument that consists in something other than having a false premise. And there can be both formal fallacies and informal fallacies. And as we proceed and talk about the formal fallacies, you'll notice that we've touched upon formal fallacies already a little bit. What we haven't done so much is touched upon informal fallacies. And we won't even exhaust the informal fallacies that are out there. There's a whole slew of them. We will cover a good deal, and we'll discover that there's various kinds of informal fallacies, and we'll talk about how they're structured so that you can identify when you're being presented with an informal fallacy. And in that way, you know that this is an argument that you can reject. You know that it's not good reasoning, even though informal fallacies oftentimes trick us or play to our psychology to get us to accept a conclusion that doesn't logically follow. All right, so with that in mind, let's turn our attention first to formal fallacies, and then we'll take a look at informal fallacies. So as we've discussed, many arguments, especially the ones that we're concerned with, are valid simply because of the structure of the argument, simply because of the form, not because of the content of that argument. So an example would be, if the grass is green, then the moon is made out of blue cheese. The grass is green, therefore the moon is made out of blue cheese. Doesn't matter that the first premise is surely false, that if the grass is green, then the moon is made out of blue cheese is surely false. It's still a valid argument because it takes the structure if A, then B, A, therefore B. That is, A suffices or guarantees B. You get A, which is the thing that we've been told guarantees B, so you get B. B was guaranteed, so you got it. So the truth of the premises would guarantee the truth of the conclusion. Now, insofar as we're just worried about arguments that are valid because of the form and not the content, then we can also look at the form of an argument to determine whether it's an invalid argument. So for instance, if the grass is green, then let me do a different one. How about if it rains outside, then the grass is green. It doesn't rain outside, therefore it's not the case that the grass is green. Well, that's going to be fallacious because it can be true that if it were to rain, then the grass would end up being green. And it could be true that it didn't rain, yet the grass was made green or kept green because we were watering our lawn with a sprinkler or some other reason besides raining. So I can make those premises true, but the conclusion false. And any argument that takes that form, as long as the content doesn't make it valid, any argument that takes that form will be an invalid argument, or at least a formally invalid argument. And that's what makes it fallacious. So that would be a case of a formal fallacy because the structure doesn't force the conclusion to follow if the premises were true. So we can determine whether a formal fallacy is committed just by inspecting the structure of the argument and then determine whether that argument is formally invalid. And what that means, because only deductive arguments can be valid or invalid, no inductive argument can commit a formal fallacy, because inductive arguments don't operate solely as a matter of their form or structure. They operate on the probabilistic reasoning, the suggesting the truth of the conclusion, as opposed to trying to guarantee it, which we can do with the form. All right, let's take a look at another example of formal fallacy, just to clarify that, or just to remind ourselves what that is. So here's our example of a formal fallacy, and it says if the president is Obama, then the president is a Democrat. The president is not Obama. Therefore, the president is not a Democrat. So this takes the same form, it has the same structure as the fallacious argument I was giving in the previous slide. It says if A, then B, not A, therefore not B. We call this denying the antecedent. And we call this denying the antecedent because A is our antecedent and premise 2 denies it. It says not A. So it says A doesn't occur. So you might think that if A is what guarantees B, that's what premise 1 says, and you don't get the thing that guarantees B, that it follows that you don't get B, that B is not going to happen. But you'd be wrong. And you would be wrong because premise 1 does not say that there's not other ways to guarantee B. It just tells you that A is one of the ways that guarantees B. Could be that C also guarantees B, or D, or E, etc., right? There might be all sorts of other ways. And just because you know one of the potentially many ways that you can't get B, that you can get B, and you don't get it, it won't follow that you don't actually get B. And of course, we can also see that it's invalid by giving a counterexample, which we've seen how to do previously. So in this case, we can imagine a situation in which Hillary Clinton is the president of the United States. If Hillary is the president of the United States, then premise 1 will be true. Because if the president is Obama, then the president is a Democrat. And the reason why that's true is Obama is a Democrat, right? So if somebody who happens to be a Democrat is the president, then it's going to turn out that the president is a Democrat. And if Hillary Clinton is the president, then it'll be true that the president is not Obama. But it will be false, given that Hillary is the president, that the president is not a Democrat, for the reason that Hillary Clinton is a Democrat. So we'd have true premises, but a false conclusion. And there's one instance we've discussed that cannot be a valid argument. And that's when you have true premises and a false conclusion. Why? Because the definition, what we mean by a valid argument, is one that if the premises are true, then the conclusion must be true. But here, we have all true premises, but a false conclusion. So it wasn't the case that the conclusion must be true. So this is our example of one example of a formal fallacy. We've already brushed up against formal fallacies a little bit. We'll take a much more thorough investigation of formal fallacies later on in the semester. For now, what we're going to do is turn our attention to informal fallacies. With formal fallacies, we have to detect the fallacy by examining the structure. But with informal fallacies, we have to look at the content. So we have to look at what's being said, what's actually being told to us. And since it doesn't rely on the structure, it turns out that both deductive and inductive arguments can contain informal fallacies. So deductive arguments are the only kinds of arguments that can have formal fallacies, but both deductive and inductive arguments can contain informal fallacies. So here we have an example of a deductive argument that contains an informal fallacy. It says 1, whatever is bright is intelligent. 2, the sun is extremely bright. Therefore, the sun is extremely intelligent. So the problem here is that one sense of the word bright is intelligent, and another sense of the word bright has to do with lots of light. So what's happening is what we call equivocation. There's an ambiguity in the word bright, and what this argument does is it trades on that ambiguity with there being, to try to get true premises, right? Because whatever is bright is intelligent, and the sun is extremely bright. Given the respective senses, those premises end up being true. But since they differ in meaning, it's not going to follow that the sun is extremely intelligent. It's not going to be bright in that sense of the word bright. So it trades on that ambiguity to try to mask or make it look like the conclusion follows when in fact it doesn't. So that's why this is a fallacy. It's an informal fallacy because it has to do with the meaning or the content of what's being said. And the content in this case is the word bright and the two senses in which it's being used, the two meanings in which it's being used. Now we're going to take a look at a few examples and do our best to determine whether we have a formal fallacy or an informal fallacy on our hands. And once you have a chance to make a decision for yourself, I'll talk about it in some detail. So our first argument here says, if TV programs become more inane, then viewers will be bored even further. Viewers will be bored even further. Therefore, TV programs will become even more inane. So take a moment, think about what kind of fallacy you think is being committed, and then I'll discuss it. If you said that this is a formal fallacy, good. The reason why this is fallacious is because of the structure of the argument. And we can see the structure of the argument by noticing it says, if TV programs become more inane, then viewers will be bored even further. So that says, if A, then B, and then it says viewers will be bored even further. B, therefore TV programs will become even more inane. So it concludes A. So structurally, we can think about what our first premise tells us and what the second premise tells us, and see that the conclusion is not going to follow. The first premise tells us that A guarantees B. We get B, and then we try to infer our way back to what would guarantee B. But that won't work for a deductive argument. Those premises are not going to guarantee that the conclusion is true. And that's because the first premise does not say that B guarantees A. It says that A guarantees B. You might be able to get B and not get A because there's other ways to get B, right? So the first premise doesn't assert the right relationship for B to be able to lead us to A. So here we have an informal fallacy. We can even give ourselves a counterexample if we want. Just imagine that it's true that if TV programs become more inane, then viewers will be bored even further. That's very likely to be true, right? Then imagine that the viewers are bored even further, but for some other reason. It's not because the programs become more inane. Maybe it's because there's even more commercial time being taken than normal, right? And if you're watching a TV shows, the program might be fine, but if there's so much commercials, you'll still get bored. So in which case premise 1 and premise 2 can be true, but then our conclusion is going to be false because the TV programs kept the same level of inaneness and did not become even more inane. All right, let's look at another example. This argument says some pieces of fruit are green, some pieces of fruit are apples, therefore some pieces of fruit are green apples. So decide for yourself whether this is a formal fallacy or whether it is a formal fallacy. If you said that this is a formal fallacy, good, it is. And the reason why it's a formal fallacy is because the categories that are being related to each other, which would be fruit, green, and apples, are not related to each other in a structural or formal way that guarantees that the conclusion will follow as a result of the premises. So we can see that by drawing ourselves a little bit of a diagram. Suppose all of our pieces of fruit fall in that circle. And what we find out is some of those are going to be green pieces of fruit. And we also find out that some of those are going to be apples. Oh, that is a bad A. That's a slightly better A. Anyhow, so our first premise tells us that some pieces of fruit are green. And in logic, what that commits us to is that there's at least one thing that is a piece of fruit and is green. So let this X represent that. And not only that, let's imagine a circumstance in which there's only one piece of fruit that is green, and it's that X. Then our second premise tells us that some pieces of fruit are apples. So let this X stand for that piece of fruit that is an apple. And again, that's the only one. So we just imagine a circumstance in which that's the only piece of fruit that is an apple. And there's nothing that's in this area. Okay. So where they would normally overlap, or where that area that is overlapping, nothing actually belongs there. That is, there's no green apples. So there's no pieces of fruit that are green apples. In that case, the X in the green circle makes it true that some pieces of fruit are green. The X in the A circle makes it true that some pieces of fruit are apples, but it's false that some pieces of fruit are green apples. So we didn't relate those categories in the right way. Structurally speaking, we didn't relate them together in the right way to guarantee that the conclusion is going to follow. So any argument that takes this form will be a formally invalid argument. Let's look at one more example. In this argument, it says the sign on the wall says, "No smoking rules enforced." No enforcement means we can smoke and get away with it. So think about this argument for a moment. Decide whether you think it's an informal fallacy or a formal fallacy. Okay. If you said that it's an informal fallacy, correct. And the reason why it's an informal fallacy is because it's not the structure of the argument that is making it fallacious. Rather, whoever said or inferred from the premise, no enforcement means we can smoke and get away with it, is misreading what is meant by no smoking rules enforced. So notice there's two ways to read that statement. One way to read it is there's smoking rules and none of them are being enforced. No smoking rules enforced. But what it very likely means is that there's no smoking rules, and those rules are being enforced. So there's smoking rules against smoking, and they are being enforced. And since that's the likely meaning, the conclusion doesn't follow from the premise. So that's a result of an ambiguity in how that statement can be read. And so it's a matter of the content, not the structure or form of the argument, and is therefore an informal fallacy.